All right, today we're on lesson 2.2. We're going to be talking about reflections. So reflection is a transformation that uses the line like a mirror to reflect an image. And so it's going to look something like this. So you could say maybe that this smiley face is your pre-image. It was there first. It got reflected over this line, the x-axis. And so it got flipped over. And so now this would be your image. It was there last. Okay, so we're going to do reflections over 4 different lines. And we'll talk about those today. So let's start with a reflection in the x-axis. So if xy is reflected in the x-axis, its image is the point x negative y. So I'm going to show you how this rule works, and then I'm going to show you how to do a reflection without using the rule. So first, let's write down the coordinates of our pre-image. So t is the point -1, 2. R is the point 3, 4. And y is the point 2, 2. Okay, so that is my x, y. To reflect in the x-axis, the rule says x negative y. So here's what that means. You're going to take your x value and keep it the same because the pre-image, it's already x. The rule says x, and so that means my t prime, the x stays the same. And then for y, it says to do negative y. So you're going to take your y value and just change the sign. So if it's positive, it's going to become negative. If it's negative, it will become positive. So if I do -2, means t prime is a -2. Okay, let's do r prime. My x stays the same, so 3. Y changes sign, so -4. And the last one, y prime. My x stays the same. My y changes sign. Okay, so that's one way you can do it, and then you can come over here and plot those points and you'll be done. Your other option, if you want to reflect in the x-axis, we know that this is the x-axis right here, this line, and all you're going to do is just count. T is currently 2 units away from the x-axis, so if I want to reflect over the x-axis, I'm going to go 2 units away on the other side, and I'm going to label that point T prime. I know I'm right because it says the coordinates were -1, -2 according to the rule, and that's what I've got. Y is 2 units away right here. So I'm going to go 2 units away on the other side. There's y prime. Again, I know I'm right because y was supposed to be at 2, -2. And that's where y prime is. And then r. R is 1, 2, 3, 4 units away. So it needs to be 4 units away on this side. So here would be my r prime. Again, I can check it right here, 3, -4. Well, hey, there it is. I'm right. So there is my reflected image. Okay, I like a reflection because it kind of reminds me of looking in the mirror. If I were to take my paper, fold it in half on my line of reflection, all those points would perfectly match up. Okay, all right, look at your next example. So my coordinates for my pre-image stayed the same. Let me pause my video and go ahead and write those in everywhere. Okay, so in reflection in the y-axis, it says if xy is reflected over the y-axis, so remember this line is the y-axis, its image is the point -x, y. So the rule is -x, y. Okay, so again, I'm going to do it both ways just to show you. So my pre-image, you'll notice, is x. My rule says to do -x. So to get my image, I'm just going to change the sign of x. This x is -1. I'm going to change the sign. It will become +1. And then my rule says that the y stays the same. All right, let's do it again. Change the sign of x. Y stays the same. Last one. Change the sign of x. Y stays the same. Okay. Again, you can count it on your graph if you would prefer. So let's look at t. This time we're reflecting over the y-axis. So t is 1 unit away from the y-axis. I can go 1 unit away on this side. There's t prime. Y is 2 units away. I can go 2 units away on this side. There's y prime. R is 3 units away. I'm going to go 3 units away on the other side. There's r prime. I can connect them. and there's my reflection. Okay, so you can use whichever method you want. You can use the rule and go through and change the sign of x, keep y the same, or you can count it and flip them over. Either way, you do have to write down these coordinates, so whatever is easier for you. Okay, note these are still rigid transformations. They keep the same size and the same shape. They're just changing position on the graph. Okay, all right, 2 more examples for reflection. So this one is in the line y equals x. So it says if xy is reflected in the line y equals x, its image is the point yx. Okay, so again, I've already written down your pre-image coordinates. The rule says to do yx. So this one, I think it's 1,000 times easier if you just use the rule. Okay. In fact, I'm not going to show you how to count it because I think it can be kind of confusing. So this one says the pre-image is xy, the rule is yx. All you're going to do is change the location. Okay, so watch this. T prime. What was x is now going to be my y coordinate. What was y is now going to be my x coordinate. All I did was switch them around. So r prime, instead of 3, 4, is going to become 4, 3. And y prime, instead of 2, 2, is going to become 2, 2. Okay, so that one didn't change because they were both the same. Switch the order. All right, and then I'm going to come over here and graph it. T prime is 2, negative 1. T prime. R is 4, 3. There's my r prime. And y prime is 2, 2. It stayed the same. And there is my y prime. Okay, so there it is. There's my reflection. Okay, let me remind you, this one was about the line y equals x. And so I do want to remind you what that line looks like. You learned about this last year in Algebra 1. This was one of your parent functions. And so I could rewrite that as y equals 1 over 1x. There's my slope. Plus 0. Meaning this is a line that has a slope of 1 and a y-intercept of 0. So when I graph it, I would start at 0 and do rise 1, run 1. Rise 1, run 1. Rise 1, run 1. So here is my line y equals x. It was that diagonal line that goes straight through the origin on your graph. So you can see that is the line I've reflected over. If I were to fold my paper on that purple line, those points would all meet up. Okay? All right, let's do one more. The last one is the reflection over the line y equals negative x. And so this line is going to be very similar to the one we just did, except this time my slope is negative 1 over 1. So my slope is negative 1, and my y-intercept is 0. So I can graph that real quick. I'm going to start at 0 for my y-intercept. My slope is down 1 over 1. So there's my rise over run. Okay, it's still that diagonal line that goes straight through the origin, but this time has a negative slope. Okay, all right, I'm going to do the same thing as before. Again, I think this is easier if you use the rule. So this one's rule is negative y, negative x. So if you'll notice, the x and the y still switch, but both of them have a sign change. Okay, so instead of whatever y was, now it's going to sign change and it's going to be first. Whatever x was, now it's going to sign change and be the last term. Here's what I mean by that. T prime. All right, I'm going to switch the order and change the signs. So the 2 will become negative 2. The negative 1 will become positive. Switch the order, change the signs. Get this one, r prime. Switch the order and change the sign. So it's going to become negative 4, negative 3. And y prime, switch the order, change the signs. Okay. Let's look back at t one more time. This one is the trickiest one, I think. Negative 1, 2 is my xy. I'm going to switch the order and change the signs. So that 2 becomes first, it comes negative. The negative 1 goes at the end, but it becomes positive. Switch the order, change the signs. All right, now I'm ready to graph it. Negative 2, positive 1. There is my t prime. Negative 4, negative 3. There is my r prime. Negative 2, negative 2. There is my y prime. Again, after you draw these, it should look like it's been reflected. It should look like that if I fold my paper on this purple line, that they're going to match up. Okay, and so that one does. There it is. Again, it is a rigid transformation because they're the same size and the same shape. They've just changed location. All right. See you later.